Lord, I want more of your ability. Oh, someone assemble. Yeah, yeah. Holy man says, you make my life so beautiful. And as you are, you have made me here. There's nothing greater than these. That's why I love you forevermore. How many of you are beautiful today? You make my life so beautiful, beautiful, so beautiful. And as you are, you have made me here. Thank you, Jesus. There's nothing greater.
Today, before we get started, let's try and recall what we learned in our previous class. Last week, we learned about two-set problems. Let's try and recall, or let's try and name the regions of these two sets before we start today's lesson. We have region 1, region 2, region 3, and region 4. Let's name the regions of these two sets before we get started to today's lesson. Here are the expected answers. Region 1 is equal to A intersection B complement. Region 2 is equal to A intersection B. Region 3 is equal to A complement intersection B. And region 4 is equal to A union B or complement. Today, we will learn something about three-set problems. Three-set problems differs from two-set problems. Before we start, let's name the regions of three-set problems. We have our first set, second set, and the third set. You can see that it has 8 regions. The first region, 1, is equal to A intersection B intersection C. The second region is equal to A intersection B intersection C complement, meaning members of A intersection B only. Region 3 is equal to A complement intersection B intersection C, also equal to members of B intersection C only. Region 4 is equal to A intersection B complement intersection C, which is equal to, or meaning A intersection C only. Region 5 is equal to A intersection B complement intersection C complement, meaning A only or members of A only. Region 6 is equal to A complement intersection B complement intersection C, which means members of C only. And region 7 is equal to A complement intersection B intersection C complement, which means members of B only. And the last region, which is region 8, is equal to A union B union C complement. And again, the union of three set problem is equal to A union B union C, or plus A union B union C, or complement, meaning the union is equal to all the members in the set. Now, if we've been known or we've got to know the regions of three sets, let's take a live problem and solve. Example 1. In a class of 55 students, some study at least one of the following subjects: science, math, English. 20 students study none of them. The following give further details of the subject studied. Science only is 4, English only is 5, math only is 7. All three subjects are 3. Science and math are 7. English and math are 8. The first question: illustrate the above data in a Venn diagram. II. Find the number of students who study English. Now, the solution. Let's have the three sets in the Venn diagram. You have the first set is equal to number of students who study science. The second to be number of students who study English. And the third set is number of students who study math. From the question, the union was given to be 55. The number of students who study all the three subjects was given to be 3. The number of students who study none of the 3 subjects was also given to be 20. The number of students who study only science was given to be 4. The number of students who study only English was also given to be 5. The number of students who study only math was given to be 7. The number of students who study science and math was given to be 7. But 3 is already there, so it's remaining 4. The number of students who study math and English was given to be 8. But 3 is already there, so remaining 5, adding up to 8. For the number of students who study English and science is not known or was not given, so let's represent it with a variable. Let's take a variable x. From the definition of a 3-set problem, the union is equal to all the members in the set. So we have the number of students who study science union, the English union, math, plus the number of science union, English union, math, all complement is equal to the union, meaning the union or the members in the 3 sets, including those who study none of them, sum up to the union. So we have all of this summing up to the number of the union, which is 55. So we have all the members summing up equal to the 55. Now, if you add 7 plus 4 plus 5 plus 4 plus 5 plus 3 plus 20 is equal to x plus 48 is equal to 55. By algebra, let's make x the subject. Before we make s the subject, we deduct 48 from the left hand side and 48 from the right hand side. So we have x plus 48 minus 48 is equal to 58 minus 48. The 48 will cancel out the 48, and the 55 minus the 48 will give us 7. So we have x is equal to 7. Now II, the number of students who study English, is all the members within this region, and we have the x, 5, 5 and 3. So we have the number of students who study English. We have x plus 5 plus 5 plus 3. By substitution of x, we have 7 plus 5 plus 5 plus 3, which is equal to 20. Let's take another live problem. Example 2. In a science class of 40 students, 22 study mathematics, 5 study mathematics and physics, 8 study mathematics and chemistry, and 3 study all the 3 subjects. If the number of students who study only physics is equal to that who study only chemistry, illustrate the given information in a Venn diagram and find the number of students who study only physics, who study only chemistry, who study only one subject. The solution. Let's have the 3 sets. We have the first set, which is the number of students who studied maths, which is equal to 22. And the second set, the number of students who study physics, which is not known. And the third set, those who study chemistry. From the question, the number of students who study all the 3 subjects was given to be 3, and the number of students who study only maths was given to be 12. The number of students who study maths and physics only was given to be 5, but 3 is already there, so we have remaining 2, which sum up to 5. And the number of students who study maths and chemistry only was given to be 8, but we have 3 there already, and the 5 will add up, making 8. The number of students who study physics and chemistry only was given to be 5. 3 is already there, remaining 2 to sum up to 5. For the number of students who study physics is not known or was not given, but let's represent it with a variable x. And from the question, the number of students who study physics alone or physics only is equal to the number of students who study chemistry only. So if the number of students who study physics is x, definitely the number of students who study chemistry is also x. From the definition of a 3 set, the union is equal to all the members in the 3 sets. So we have the number of students who study maths intersection physics intersection chemistry is equal to the union. So if you sum up all this, it should be equal to the union 40. So we have 12 plus 2 plus 3 plus 5 plus 2 plus x is equal to 40. Summing up will give us 24 plus 2x is equal to 40. Now let's make x the subject. Before we make x the subject, let's eliminate 24. Now let's subtract 24 from the left hand side and 24 from the right hand side. So we have 24 minus 24 plus 2x is equal to 40 minus 24. The 24 will cancel out the 24, and the 24 will be subtracted from the 40. So we have 2x is equal to 40. Now let's divide through by 2 to make x the subject. By division, we have 40 divided by 2. So we have x is equal to 20. For our first question, the number of students who study physics only, which is x, is equal to 20. The number of students who study physics only is 20. The second question is the number of students who study chemistry. Here are the region. This means that all the members in this region study chemistry. So we have 5 plus 3 plus 2 plus x will sum up the number of students who study chemistry. So we have x plus 5 plus 3 plus 2. Substituting x equals 20, we have 20 plus 5 plus 3 plus 2, which is equal to 30. So 30 students studied chemistry. Here comes the end of the lesson. Let's take an assignment and try our hands on it for our next class. A national soccer invited 20 players for a match. 8 of them were attackers, 12 of them were defenders, and 12 were midfielders. The coach realized that 5 could play both in the attack and in the midfield, 6 defense and midfield, 2 only in attack, and 3 play all 3 roles. A. Illustrate the information on a Venn diagram. B. Find the number of players who can play I. Only midfield. II. Exactly 2 rows.
Lord, I want more of your ability. Oh, more, someone assemble. Yeah. Holy Manesset, you make my life so beautiful. As you are, you have made me here on earth. There's nothing greater than these. That's why I love you forevermore. How many of you are beautiful today? You make my life so beautiful, beautiful, so beautiful. And as you